We are here to help.
Confidence intervals are determined using a point estimate from a sample. Since we will be estimating the population mean, our point estimate will be the sample mean, x bar. A confidence interval is made up of the point estimate and the margin of error. With each confidence interval, we need a confidence level. This tells us the probability that the true population parameter lies within the range of the confidence interval. We will be covering two scenarios when creating confidence intervals to estimate a population mean: when the population standard deviation is known and when the population standard deviation is unknown. Depending on the scenario, we will either use a z-test or a t-test to find our confidence interval. Before we create our confidence interval, we need to make sure we know two very important things. The sample needs to be a random sample, and the sample size needs to be at least 30 or normally distributed. 250 Ontario students were randomly chosen to respond to a survey asking them how many times they eat out in a week. Out of the 250 students, the average number of times they ate out in a week was 4. The population standard deviation is 1. Construct a 95% confidence interval for the mean number of times a student in Ontario eats out in a week. We know our sample is random, and our sample size is larger than 30, so we can proceed to finding our interval. We also know our point estimate being the sample mean. We know the population standard deviation, and we know our confidence level. Because we know the population standard deviation, we will be using a z-test. The complement of the confidence level is our alpha value, which we use to determine the z-scores. Alpha is the combined area in the tails of the normal curve, so each tail has an area of alpha over 2. Confidence intervals always result in two-tailed tests since they have a lower and an upper range. And our confidence level probability is the area of the curve between the two tails. In this example, the central area is 0.95 and alpha over 2 is 0.025. Now we can find our z-scores using the z-table. This is a cumulative z-table and uses the area to the left of the z-scores. The z-table you are using may be different. We're looking for the corresponding z-scores for our alpha over 2 value in the tails. Notice that the areas in the tails of the curve are the same, so we only have to find one z-score. We will use a negative z-score table to find the z-score for the left tail first. Because the value for alpha over 2 is an area, we need to look in the inside part of the table. Once we have our alpha over 2 value, which was 0.025 in our example, we can follow along the row and column to find the z-score, which we see is negative 1.96. No matter the type of z-table you are using, you should still get a z-score of negative 1.96 for the left tail. Now that we know one z-score, the other one will be positive 1.96. And we're ready to calculate our margin of error. The formula for margin of error in our example is the z-score times the population standard deviation divided by the square root of the sample size. We will use the positive z-score to calculate this. And we can calculate our confidence interval. We say that we are 95% confident that the true value of the population mean, that is, the mean number of times that Ontario students eat out per week, lies between 3.876 and 4.124 times. When the population standard deviation is unknown, we use a t-test instead of a z-test. A random sample of 29 college students from a normal population were surveyed about how many hours a week they spend studying. The sample standard deviation was 2.5 hours, and the sample mean was 5.75 hours per week. Create a 95% confidence interval for the population mean. The sample is random, and the population is normally distributed, so we can proceed. In this example, we don't know the population standard deviation, only the sample standard deviation. We have the sample mean, our sample size, and because our confidence level is 95% or 0.95, our alpha level will be 0.05. The process to calculating our confidence interval will be similar, but this time we need to use a t-test since we don't have the population standard deviation. Since our alpha value is 0.05, our alpha over 2 value will be 0.025. Now we can find our t-score. The t-score for 0.025 in one tail and the t-score for 0.05 in two tails, both with 28 degrees of freedom, will be the same, so we can use either one. On the t-table, locate the degrees of freedom column and find 28. Then, locate the column for an alpha value of 0.025 in one tail or 0.05 in two tails. And follow across and down to the t-score, which is 2.048. Now we have our positive t-score. We know the other one will be negative 2.048 since the area and the tails are equal. Now we can calculate the margin of error. We will use the positive t-score for this. And now we can calculate our confidence interval. We are 95% confident that the true value of the population mean, that is, the mean number of hours that college students spend studying per week, lies within the range of 4.799 hours and 6.701 hours.